All right, today we are diving into something truly mind-bending. It's a new theory called Conformal Emergent Reality, and let me tell you, it is ambitious. It's trying to solve some of the biggest puzzles in all of physics with one single radical idea. And honestly, it might just change how we think about, well, everything.
So you might be wondering, why do we even need a new theory? I mean, aren't we doing okay? Well, the truth is, for all of our incredible successes, modern physics is kind of hitting a wall. There are these huge fundamental questions out there that we just can't seem to crack.
And we can really group them into let's call them the four great puzzles. First, you've got the whole dark universe problem. I mean, think about it. 95% of the cosmos is made of dark matter and dark energy, and we have absolutely no idea what they are. Then there's the Big Bang itself. What actually lit the fuse? We call that the inflation puzzle. We also have the hierarchy problem, which is basically asking, why is gravity so incredibly weak compared to the other forces? And, of course, the big one. How in the world do we get Einstein's beautiful theory of gravity to play nice with the utterly bizarre rules of quantum mechanics?
Now, for decades, physicists have been banging their heads against these problems, treating them as separate issues. But what if they're not? What if they are all just symptoms of a much deeper misunderstanding of how reality works? What if there's a single idea that can make them all just click into place?
This is where Conformal Emergent Reality, or CERM, just flips the entire script. You see, we're all used to thinking of space-time as the background, right? It's the static, fundamental stage where the whole cosmic drama plays out. But CERM says, nope, you've got it wrong. Space-time isn't the stage, it's one of the actors. It's something that emerges from a deeper, more fundamental geometric blueprint.
So, what's running the show? What's controlling this fundamental blueprint? Well, the theory proposes this single, all-encompassing thing called the omega field. The best way to think of it is like the master architect of reality. It takes this raw primordial geometry and literally shapes it into the space-time, the matter, and the energy that we actually see and experience.
And this omega field kind of has a split personality. It has two jobs. First, there's the geometric part. This acts like a cosmic safety valve. It smooths out the fabric of space-time in really extreme places, like inside a black hole, to stop the laws of physics from just breaking. Then you have the chronos part. And this is the engine. It's the thing that's constantly driving the expansion of the universe, and, as we're about to see, it's the reason time only ever moves forward.
Okay, that's a really cool idea, right? But does it actually solve anything? Well, let's see how it tackles that first big puzzle, the mystery of the dark universe.
For years and years, we've been hunting for some kind of new, exotic particle that could be dark matter. We've built massive detectors, spent billions of dollars, and found nothing. So CERN comes along and asks this really provocative question. What if we've been looking for the wrong thing this whole time? What if dark matter isn't a thing at all?
Instead of a particle, CERN says that what we call dark matter is actually a stable, self-perpetuating ripple in the omega field itself. You can imagine it like a persistent knot in the fabric of geometry, something they call an omegon soliton. This thing isn't made of matter. It is a localized warp in space-time that bends light and holds galaxies together, perfectly mimicking all the gravitational effects we see from dark matter. No new particles needed.
Okay, wow. So that takes care of dark matter. But what about its partner in crime, dark energy? You know, that mysterious force that's making the universe expand faster and faster.
And the answer here is just beautiful. According to CERN, dark energy isn't some extra energy filling the void. It's the chronos engine of the omega field doing its thing. You see, that part of the field is just defined to grow, always. And its constant, relentless, built-in growth is what we observe as cosmic expansion. The universe is flying apart because, at its most fundamental level, the engine of time is pushing it.
And that brings us to maybe the most profound piece of this whole puzzle. Because this theory doesn't just talk about the cosmos. It tackles a question that you and I experience every single second of our lives. Why does time have an arrow? Why can we remember the past, but not the future? The theory gives us a three-layered answer. First, way down at the quantum level, there's a fundamental uncertainty that basically forbids time from running backward. On top of that, you have the Omega Chronos engine we just talked about, acting as a one-way only clock for the entire universe. And finally, because of this setup, the famous law of entropy, the idea that things always get more disordered, is no longer just a statistical probability. It becomes a hard and fast rule of geometry.
Put those three things together and they lock time into a single, forward-moving direction. And what this all boils down to is something huge. In this model, the second law of thermodynamics, one of the bedrock principles of physics, isn't something we just have to assume is true anymore. It becomes a provable theorem. It's a direct mathematical consequence of the universe's fundamental geometry.
Now look, I know this all sounds incredible, maybe even a little too neat, but for any theory to be actual science, it can't just be a good story. It has to make specific predictions that we can go out and test and potentially prove wrong.
And CERM delivers. It predicts very specific things we should be able to see, things like unique fingerprints in the leftover light from the Big Bang, a very particular history of how the universe's expansion has changed over time. It says the way light bends around these omegon solitons should look different than with standard dark matter, and it even predicts a different pattern for how the very first galaxies formed. And the best part? These are all things that our next generation of telescopes, like the James Webb, can actually go look for.
So in the end, CERM paints this radical new picture of our universe. It gets rid of the need for dark matter, dark energy, and cosmic inflation, and replaces them all with one single, elegant geometric principle. And it leaves us with this one truly profound question to chew on. Is it possible that the reality we experience, all of it, with its vast structures and its relentless flow of time, is just an echo of a deeper, more fundamental, timeless geometry?